my name is Paisley Code. My partner for this project is Harrison Williams, and the assignment is embedded crypto. So here we're essentially looking at two different encryption algorithms, AES and Chacha20, and we're comparing their execution time on the MSP430. So first, we're looking at AES right now, and we have a system here to sort of measure the time. So first, we essentially calculate the number of ticks by keeping track of each interrupt for time A0. And here we enable the interrupt, and then we also look at the hertz. And here we're calculating by dividing by 125.00, I guess 12,500. And this is essentially because AES takes a lot shorter of a time to run than Chacha20. So you can see here that this is a much bigger number because it's going to take a lot longer, and it just makes it easier and ensures that the time calculation doesn't overflow or anything. So here we also notice that we have the starting number, and then we set that equal to the ticks, and then when we want to calculate the elapsed time, we sort of subtract the current number of ticks from the start. And you can see this implemented down here in main. So here we have the similar stuff to before for the UART where we set it up. And here we have the start timer, and we also have this line here, and this is for when we're measuring it with the oscillator. Since this port 1 will sort of be like switched on, and then the oscillator can sort of read, okay, port 1's been switched on, and then it'll be able to notice, oh, we can notice when port 1 is then switched off, but that's going to come a little bit later. Here we have our test encrypt function, where we essentially sort of like run the number of iterations in order to ensure that it's the correct length. And then here we use UART to output it to the main computer, and we output the specific time that elapsed. So we have a really similar system for Chacha20, which I sort of hinted at before here. You can sort of see the same system here in main, where we have like port 1 switched on, port 1 switched off, output the information using UART. So first, I'm going to run this with AES. Starting, and in the meanwhile, I'm going to set up PuTTY. And so now we're listening in on COM4, similar to what we explained earlier in the last project. And then we can see here 10 Hz ticks, 36. And now we're going to do the same exact thing for Chacha20. All right, and this is going to take a while, so once this is done running, I'm going to pause, and then we'll come right back. Yay, so that took a while, so now we're coming back, and we can see that we have 2 Hz ticks with 146 seconds, I think. So now I'm going to explain the oscilloscope readings. So essentially this is a screenshot of the results taken from the lab. So it's not going to be conducted live, but I'll still explain the whole process. So remember earlier when I explained that we trigger port 1 on, and then we trigger it off again once the encryption's done running. So this is essentially just us reading that trigger on and then trigger off. So you can see here it starts at 0, and then right here the encryption starts, so that jumps up to 1. It continues, and when the encryption's done, it goes back down to 0 again. So you can see here that we have the time ruler. We use the ruler tool in order to sort of like measure the start and the end. We can see here the seconds, which line up to our result from the Hertz measurement that we got using UART, or the time clock mechanism. So here for Chacha20, we're using a really similar method as well. We can notice that Chacha20 takes longer to run, so it's a little bit longer. We have the same exact system. Port 1 is triggered on, it starts, and then at the end it's triggered off again, and we use the ruler tool in order to measure the length of how long it's on. You can see here that we have the seconds marker here, which we'll use later on in order to calculate the power consumption. So here you can see us using the oscilloscope and other tools in order to measure the power consumption of our board and the encryption algorithms. So as you can see here, we connect input and output connections on either side of the resistor. And here we have our resistor here, and we know that it's 1.2 times 10 to the power of 3 ohms, so that's like a constant that we can use in order to calculate the current from this setup. You can see it's connected using the breadboard. So here are our results from the program from Picoscope. So you can see here that we have the start power consumption, and then you can see how it goes down. So if you look up here in the ruler section, same thing as before, we have horizontal rulers to look at the power consumption. And first we have, or to look at the voltage change. So you can see here that it starts at 3 volts, so 3 volts is what was sent into it. And the change is 305 millivolts. So you can see that the change is much smaller, but there is a change between them, so we know that there was a difference. So now we're using all the information that we gathered and putting it into the formulas that were supplied in Canvas and outside of Canvas to sort of like figure out what the energy consumption is. So you can see here that the voltage was 306 microvolts and 1.2 ohms. So if we divide the two of them, then we get 0.000255 amps. Next up for AES, we have our voltage, which is the same since we're using the same tool. And then we're multiplying by the current, which is the amps that we calculated before, and then the time, which was 3.6 seconds, according to the oscilloscope reading that we had earlier. And there we get 2.7 microjoules. And then for Chacha20, it's basically the same number since everything else was kept the same, except this one took 74 seconds. So here we have 56 microjoules instead. So here we can sort of see that the energy consumption of Chacha is way higher because it takes so much longer to run, while for AES it's significantly smaller since it takes a shorter amount of time to run. So from here, we are able to calculate the total energy of both encryption algorithms and compare them using the same metrics, using both UART, the oscilloscope, and I guess the oscilloscope again in order to figure out the amount of energy consumption. All right, thank you for listening. Have a good one.